I would like to thank the organizers for inviting me. I did write a discussion paper about inferring modal split from mobile phones because they thought I have an added value to what's already being presented. And yeah, I would like to catch up on yesterday that the mobile phone is a device giving you information from door to door. And we have been working on extracting information not only in terms of route, but also in terms of travel modes. So I just have 10 to 15 minutes as a presentation, so I will only present part of the work and things which I think might be the most interesting to you. So I will shortly introduce the principle of active travel mode inference. I used the nomenclature of the ITF paper. I would like to present you some issues with data quality. Luis yesterday said he's a modeling guy, a modeler guy. I'm more the data guy. And he said, yeah, discuss it with the companies providing the data. So I would like to give you some take-home message or some insight what is still open and what are the issues in terms of data quality when you do such a thing. And directly derived from that is some policy recommendations we thought about. So the principle of active travel mode inference is you record not only location data, so this is a person on the move, walking or riding the bike or taking the subway, etc. So you're not only recording the location data, but also sensor data, which are built in the smartphone. One of the most important is the accelerometer, which measures the forces impact on the smartphone, typically used for flipping photographs if you flip the device itself. Gyroscope, magnetometer. So there's a lot of sensors built in, and you can use that to derive travel modes, for example, a set of 8 modes. So what usually happens is people walk around, and after the trip, for example, these sensor data and location data are transferred to a server where the actual analysis happens. This is because the algorithms are rather involved, which we see later. And you see on the right-hand side, if you have a dedicated travel survey, smartphone-based travel survey solution, you get, for example, an automatic travel diary. This is a solution from our house, from AIT. It's called Smart Survey, where you have a really detailed trip information, intermodal trip information from starting to the from the beginning to the start. This is a typical trajectory from me, an intermodal trip. At least at the beginning of the year when I still used to use the public transport. So I start a short walking leg or trip stage. Then I hopped on the bus. Then I have again this pedestrian stage, have a subway ride. And finally, I take a commuter train to the place where I work. So you can use this if you analyze sensor data for the dedicated travel surveys. But you could also build it into other third-party apps. For example, if you think of a travel planner or a mobility as a systems solution, you could also capture the real travel the users carried out after planning a journey. What we worked the last 2 years is about the solution of automatic ticketing for public transport, where the idea is that people tend to forget to indicate when their trip stopped. So why not automatically infer the public transport routes and then charge the people accordingly. One could also think of building in this functionality to a behavior change or gamification apps in terms of your travel behavior change and policy things. So there's a lot of application of building that in and getting intermodal trip data. So this is just an example of a trip involving 3 stages. And the first plot shows you the velocity in terms of meters per second. This is the very intuitive thing. You have the velocity, you have the subway and the stops in between. Of course, the velocity is larger for subway than for walking. And many people, the first time confronted with this phenomenon, the first conclusion is, oh yeah, I have GPS and I measure the velocity and then I can discriminate between the travel modes. It's a little bit more complicated. So what you see in the second row is the accelerometer measured during these stages. And I try to, when I first looked at this, these curves we had, we thought it looks a little bit like in the audio studio. And we were thinking about what just if you modulate these waves into something and make sound of it. And this is a walking pattern. You hear the walking pace out of this pattern. You're a regular recurring pattern. So the next thing is then you do audio analysis. No, we don't. This is just a visualization or demonstration. What's the difference? As opposed to the subway, of course, there is much more quiet and some the curves and the stuff. But in fact, you have these data, and what I have to point out is that this is a hard machine learning or a hard pattern classification problem. Why is it hard? You have this typical signal, and what it is determined by a travel mode. But the problem is that it's determined also by many, many other influence factors. You list it all on the left-hand side. The person driving influences the data, the travel route. Is it paved, the road or not? The traffic state, are there many congestions or not? The type of vehicle, the tracking device itself, etc., etc. I have a table in the paper of all the influence factors. With every influence factor, determines also this curve and these sensor measurements. And the problem is, if you don't have enough representative data of that, the problem is that you will have spurious correlations. And I just wanted to include this fun slide. I think most of you are aware of it. You must be very careful if you relate to different time series and draw conclusions about it. Here, it's free, so I'm allowed to present it. It's www.spuriouscorrelations.com. You see here an example. Per capita consumption of mozzarella cheese correlates with civil engineering doctorates awarded. And you must, of course, be careful to draw conclusions about the causal dependencies. The second phenomenon, which is hard, which makes this travel mode inference hard, is that the location data are sparse and noisy sometimes. There was a pre-question from Marie, I guess, asking, isn't GPS the most accurate? It is, of course, if you are on the surface and not in the underground and not traveling in the subway, or are not in a region or in the street which is sided by high-rise buildings. So this is just to illustrate an example which we recorded. The red line is an intermodal journey comprising a bus, an underground and another bus, and the circles, some are so small that you don't notice, but the bigger the radius, the larger the uncertainty is. And nowadays, these measurements are usually taken from the operating system, from the smartphone. So on the iPhone, for example, you get a location and you don't even know which source it comes from. You get a location and a measurement. I wanted to indicate in this example that sometimes it's even wrong what the smartphone operating system reports. It's far away from where you are, but the certainty is quite high. So you cannot even rely on that what is delivered. So this makes the problem quite hard. And what we usually do is you identify the most likely route through a transportation network via map matching. We already heard it from yesterday. You snap what you've measured to the route, which introduces other problems because you must rely on this data source, that it's up to date, that is complete, that it is correct. For example, OpenStreetMap has a lot of erroneous data or incomplete data. At the moment, the solution we match what we have measured, initial models of transport modes, to a public routing service like Google. So really we connect it to the Google router, and then you get a consistent result, the most likely route through that network. This is especially helpful in urban areas where you really, or you think of Paris with this large underground network where you don't really have GPS data. So I wanted to raise an issue with all these. You have the phenomenon of influence factors and the location data, which might be sparse and noisy. What is quite unique in this field of work is that there is currently a lack of comprehensive reference data sets, as opposed to other scientific fields or other fields like you think of computer vision, pedestrian detection for automated driving. There is a large set of renowned or accepted reference benchmark data sets. If somebody publishes a paper, you can really compare it to the other methods. This is really in this field quite scarce. One of the most important things that started 2 years ago is the Sussex Huawei locomotion data set. This comes from a completely different area. It's the activity recognition in the course of the so-called UBComp conference. What did they provide was 750 hours of labeled data. And you see here on the right-hand side, this poor guy had to walk around for several months, had to wear 4 different or multiple smartphones on different positions and recorded it and provided the true mode of transport for it. So in this competition, there are 8 different modes of transport. This was one of the first initiatives to provide a data set where you could submit your solution and look what came out. And the overview paper is quite telling what came out in terms of data quality. So if you think you have a glossy folder for posting about 90% accuracy, or you have a paper, of course, everybody is above 90% accuracy. And the red line indicates what they reported on the data they had. These are 19 groups. So most of them are in the vicinity of 90%. But what was really relevant was the blue curve. This was the performance of the solution on data which were not seen before, so which were not used for training. And here you have really a drop, especially an increasing gap between what has been reported and what is really on an independent data set. So only 5 solutions, so 4 here on the top 4, have a reasonably low gap between the performance on the training set and the test set. This is another one. It's a little bit lower, but at least they were, yeah, it is representative of what can be achieved. Just a small advertisement. This was our first place in this, 4th place in the competition. That's why I still have this mark here. And one must take into account that this was only on data from one person on one position. So there is a data set, but still here, and the submissions here were very involved, like deep learning, all the buzzwords you hear today about artificial intelligence. They had really complicated, sophisticated solutions, but it still tells you you have to take into account or you have to know what you do. Because here was a particular phenomenon that many algorithms learned that you have 60 seconds and the next 60 seconds will be very similar to the ones before. So he had to do some reshuffling, but that's a technical detail. My message is you should be very careful when some performance figures are indicated. And we concluded, at least for the papers, if every week there are 2 or 3 new papers about it, they are not very meaningful because they are not revealing the framework, the conditions, how it was evaluated. So we, just a small group of data collection and analysis, what we would like is to foster the collection of comprehensive reference data set to make it possible that it is that you can collect more comprehensive, covering all travel modes, combinations of travel modes, vehicle types, to cover these influence factors as well. I introduced at the beginning. And one could use scripts instead of daily routines so that you not have the same route over and over again. And it could also be an advantage because when it does not involve the home location, it's better in terms of privacy. It's also on a side note, this SHL challenge did record location data, but although it was in the third year, they did not yet reveal location data for the challenges. And what we observed was what I mentioned before, operating system gain access to fine-grained data, but they make it increasingly difficult. We heard yesterday from Luis, of course, they do all the stuff anyway and transfer and you don't know. What we noticed is, of course, if you have, for example, Google Maps running, localization works well. If it's not running, it becomes more and more difficult. So they increasingly make it more complicated to access this. This is in favor of the user, of course. Apple just started from yesterday a new policy, but still it should be possible to get access to these fine-grained smart location data. Because if the user agrees on it and has informed consent, it should be possible. And the third one is related to the first one a little bit, and also to the things that have been discussed already yesterday. There should be exchange frameworks. Also in this thing, there should be a collection of best practices and guidelines in common data formats. We are aware that it is not that interesting for maybe traffic modelers, but this would be an important component to really get better quality and more reliable results, and yeah, maybe less disappointment in the practical results. And this is my short presentation about this topic, and I'm of course happy to answer the questions now. Thank you.